Window. So this is the first time we've met, by the way, and I'm really excited, so I need to get that out of the way. So I wanted to start by asking you a question about your work, really, and what's really exciting to you and unique, right? We're all security people here. We're all a little bit open source biased, I hope, by the fact that we've shown up here today. But I wanted to ask you a little bit about what's unique in the work that you do with device security. And I wanted to start there.
Thank you. I'm also excited to be here. So the company that I founded is called Thistle Technologies. And before I started this company, I was a CISO and a CSO at Square, at Fastly, at Mozilla. And then I was the Chief Software Security Officer at Intel. And in that role, I got to see kind of an industry scale perspective on device security. And it was very distressing to me to see how far behind devices were in terms of platform security compared to general purpose operating systems and even the work that goes into mobile operating systems. And so I started to see this over time as pretty much the biggest problem in security, that even if we know what to do, it just wasn't making its way into these devices that are then attached to critical systems in the real world that have a physical capability and live for decades. These devices are out there for decades. So whether it's a car or it's the infrastructure that controls power and water or telecom or medical devices, you name it, right? These devices have both high security risks, low security investment, and then are out there in the world for decades doing whatever function they have. So trying to figure out how to make it easy to get the kinds of security capabilities that we already know are required to be in these platforms, how to make it easy for the folks who are making these devices to incorporate those capabilities into these projects. So that is the core of what I'm building at Thistle Technologies, but I actually know that you folks also contribute a significant amount of these kinds of capabilities, because we don't want folks to reinvent the wheel over and over again, right? Which is essentially what's happening right now, because a lot of this work is really hard to get right and really easy to get wrong. So taking well-tested implementations and making them more accessible to device makers is going to be a lot more effective than hoping that they're all going to build these capabilities from scratch. So when you are building these kinds of capabilities, considering maybe if you guys are working on, let's say, server technologies or systems that have generally more resources, you might be thinking about performance, but you might not be thinking about footprint. You might not be thinking about memory usage the same way you might have been if you were doing this work 10, 20 years ago. But constrained systems have to think about these things, and this is one of the reasons that a lot of device makers don't choose open source libraries that weren't necessarily implemented with devices in mind, because those are things that you really still have to consider. Even power consumption is a huge consideration for device makers, and it's one of the reasons that a lot of work that exists out in the world that is built to security resilience, with security resilience in mind, doesn't quite meet the mark for a lot of these device makers.
Oh, that's really interesting. We did not overlap at Intel. I wish we had. So your career spans both open source and non-open source software, right? Sure. You've done and seen a lot of things. Can you tell us a little bit about development cycles, right? Depending on what you're working on, development cycles, release processes can be very rapid or not, right? What are the unique considerations in these different environments? Proprietary versus open, rapid release cycles versus maybe delayed release cycles. How does that work in your mind?
Sure. So I owned all the security and privacy features at Apple for iOS and OS X for almost 6 years. And so that is like the most proprietary environment.
Yeah, for sure.
So at Apple, you ship the software when the hardware is ready, right? So whatever is ready when it's time to go out, that's what goes out, right? There's a little bit more flexibility these days, but and more of an expectation that you can ship major features as part of a smaller update. But when I was there, starting in 2010 to 2016, it was basically whatever is available, that's what goes out. And so that ends up influencing a lot of investments, right? Because if you can't get it done on this schedule and has to bleed into the next, it might not ever get done. So being able to plan ahead and to say that, like, okay, we're going to make this investment, it's going to take 2 years, even if it actually takes 13 months, because that's what the cycle looks like. It's difficult to get all the moving parts in place, all the people on board, all the resources that are required to justify that kind of work in those spaces when your release is hardware driven. One of the things I really like about software cycles is that they can go out when they're ready. And of course, you still have to plan around revenue, right? Because if you have nothing new to sell, then you don't make any new money. So this is more of like the Microsoft model. So you still need it to be ready when it's time to go out. And a lot of those are driven by cycles around when enterprise actually buys new hardware, even if the hardware is not yours, right? So because they might update their operating system license at the same time that they are deploying more capable systems, for example. So there's more flexibility today than there has been in the past, but it ends up driving, let's say, the willingness to do things that take a long time. Whereas open source projects, especially if they're driven by foundations or by, so Mozilla is kind of like my other counterexample of this. I was the chief security something or other at Mozilla a long time ago. But being able to plan a really, really long timeline and say, like, this is going to take 2-3 years. We don't have the resources now. We have to engage the community. We have to hope people want to sign up to do this kind of work. We need to maybe convince this corporate sponsor that it's aligned with their best interests, et cetera. And there's a lot of so in that role, right, there's a very, very, very small number of people who are actually paid by Mozilla to do this work at the time. And then there's a set of people, now in the hundreds, that are paid by some other corporation to do this work if it aligns with their corporate objectives. And then there's thousands of people who do some of this work, a lot of this work, who do it because they're interested in it and they want to. And so they'll do the work if it aligns with their interests and their free time and their vacation schedule because they're college students or what have you. And then there's a whole bunch of folks who show up for like a few minutes, do something, and then move on. So like people who run nightly builds or something along those lines. So trying to organize this set of resources through which you have no authority, you're only trying to like organize with influence, to try and get that objective that you know is going to take multiple years. Is a different kind of constraint. So I'd say the investment of what needs to happen is not actually that different, but how you get it to happen is incredibly different. And the trade-offs you make, knowing that, let's say this is not the fun work, like for example, fixing a bunch of vulnerabilities in someone else's code that you didn't write, that's not fun for most people. Some people really enjoy that, but not everybody. So trying to get folks to invest in that because it is what's required in order to make sure the product continues to be successful. It's still got to get done, but it might not be able to invest in it the same way that you could invest in, say, that new shiny feature that like you get to point out to your grandmother and say, like, I did this, and you can see it, and it feels like something, as opposed to maintenance work or resilience work, which is critical to the success of the project, but it's harder to point to that one specific thing that you did that someone can touch.
Oh, yeah, I understand what you mean, yeah, for sure. So given that we're all here, right, for open source software, I think we all understand how critical open source software is today, right? It's enterprises, everyone. It touches most people on the planet and elsewhere, frankly. We've got open source in space. So what do you see as the biggest security challenges at kind of a high level that the open source community as a whole is facing?
I would say complexity, and this is actually a problem I don't have a great solution to, but for any large-scale project, you're going to not write everything yourself. You're going to incorporate a bunch of different libraries, and they probably incorporate a bunch of different libraries as well, and you eventually get to a point where you don't actually know all the things that are present in the system. So, or you do, but it requires a significant amount of work to maintain it in terms of making sure that the vulnerabilities that are present in this library that you incorporated maybe like a couple years ago, did you actually have a plan to move up to the latest version of this? And moving up to the latest version means changing the way the APIs are called, and that might be a breaking change, so you have to go fix this. Oh my gosh, it just goes on forever, and it's true for then everything that you incorporate. So maybe it's just easier to stay on that version, but that version might have a vulnerability or many vulnerabilities that have been identified in the 2 years since you incorporated it, and are you actually out there investigating all the different, let's say, fixes that went into this. And sometimes you don't even know that it's been fixed, because if it's not identified as an individual vulnerability and it's, say, a set of vulnerabilities that have been fixed through a major update, let's say a rewrite, right? That's not something that is necessarily going to jump out at you. So you might not ever get the security improvements if you don't, or if you're not able to move up to that new revision. So it's I'd say this growing complexity and trying to understand what's in it, which is why this work with software bill of materials is important, but also incredibly difficult, because we're arguing about like what format it should be in, which is just frustrating for me, because in my role as a CISO, I was just happy to know what was in something, so I could figure out if this vulnerability that is present in, let's say, a widely used library, it actually impacts these different systems. And for some of these commercial implementations, if you don't know what's present, it's really hard to know now you're vulnerable. And then you take that problem and it's even worse on devices, because they have the same degree of complexity because they've incorporated who knows what. And then it's a little black box that sits on your network with all that exposure, and it's basically impossible, well, not impossible, it's incredibly impractical to evaluate whether or not this device is going to be vulnerable to that specific vulnerability in a library that was incorporated by a project incorporated by that specific device implementation. And this problem only gets worse every year. So I'd say in terms of open source software, this is actually a commercial problem, because they incorporate open source capabilities, and it's a problem for open source projects because we all incorporate everything from each other, which is fantastic. It means that we're able to create much more robust systems much more quickly, capabilities that you wouldn't be able to if you had to write everything yourself. You wouldn't be able to do it. So it's both a huge boost to our productivity, our capability, the kinds of projects we can create, but then also the complexity creates a security problem that only gets worse every year.
I so appreciate that you mentioned the complexity. I feel like software today is so complex, it's very hard to get the visibility into it, and I appreciate that you mentioned that. So given all of those challenges that you just mentioned, when we consider smaller projects, like take Kubernetes aside, right, things that have very complex communities around them and groups of people supporting them, how can smaller projects with more limited resources prioritize security without being overburdened and failing at some steps of the way?
Yeah, so even if you don't have, let's say, security expertise specifically on your very small team, there are a lot of things that you can do with a small team that will dramatically reduce the security risk for your project. And the first of these is to move to memory-safe languages. Especially since I spend a lot of time in the devices space, I know not everybody can choose a memory-safe language for everything, but considering that 65 to 70% of the vulnerabilities in the Common Vulnerability Database are memory corruption issues, if you can move to a memory-safe language, then you are going to dramatically reduce the opportunity for memory corruption issues to potentially be vulnerabilities on your project. So that is the first. And the second is to reduce complexity. If it's easy to understand, then it's easy to identify where security problems may exist. And then being able to reduce your attack surface as much as possible. So minimize the entry points to the system, or at least identify those. Make sure input validation is happening at all those entry points, which is another reason why you want fewer of them. And then critically, and I think this is the hardest for a lot of folks who've made a huge investment in creating a lot of capability, a lot of functionality for your projects, and that is to consider carefully which of these capabilities are in use by the vast majority of your users. And if there's capability that is in use by a really small percentage of your users, then to modularize it, or maybe get rid of it altogether, so that the vulnerabilities that are present in software that's not being used by most of your users, those vulnerabilities then don't impact the rest of your base. So if you decide to get rid of that functionality, then it's not a vulnerability for the rest of the base anymore. And if you're able to modularize it, then only the people who need that capability will have to accept the risk of executing that code. And this is especially true for features that you haven't looked at for a couple of years, features that are not being exercised very often. All that stuff is more likely to be the place where those vulnerabilities crop up. So we'll call this modularization, right? Taking out that capability so that what remains is the code that's being used by the vast majority, that is well exercised, and that these kind of edge features are not able to, the risk of these capabilities are not going to impact the vast majority of your users.
Okay. So open source, again, it's about people, right? It's about people collaborating. It's a very collaborative, distributed environment, where security tends to be more about restriction, right? Maybe restricting access. How do you balance the concerns of distributed teams, openness, the values of openness, versus securing critical systems and data? Is there a conflict there at any point? Where's the balance?
I don't necessarily see a conflict there. So like making the capability of understanding software available broadly is not in conflict with restricting access to data or access to, to change data, right? So if we're thinking about, let's say, who can commit to your source code project, you don't want just anybody to commit. You want to review the commit. You want to assess whether it's a capability that actually improves the project. So it's less about who the developer is necessarily, but more it's about whether or not this contribution is going to make a meaningful, useful improvement in your code. So I think of it more like that, but like letting people see the code, right? That's not undermining the success of the project. It's restricting access to who gets to contribute. And again, it's not who, it's whether the contribution makes sense. So similarly, if you're building a large-scale system, which code that you choose to put into the system is not the secret, or it's not what you restrict necessarily. Knowing about what's in there, it's the data that your system collects, or the data that your system uses. That's where you need to put integrity around, well, these folks have access to it. These folks are the administrators of this data. These are the custodians of this capability. So I don't necessarily think that it's in conflict at all.
Okay, great. What do you think we as a community, looking forward a bit, I think we talked about kind of the current state of affairs, but looking forward, what do you think are the biggest concerns that we should all be aware of and watching out for over the next, say, 5 years?
Again, the complexity issue, I feel like is like top of mind for me. From a software developer perspective, from a product perspective, from a CISO's perspective, the trying to minimize risk in the environment, for having built very large-scale projects like operating systems and web browsers, and I feel like the complexity aspect from a security perspective is one of those that touches like literally everything that we build. I would say that we're able to mitigate some of this with, I guess, moving to those memory-safe languages, but it's not something in order here. It requires work, and it requires the work of all these development teams to build the systems we need to understand things. And I'm going to add to this aspect of data collection, because for a while we were moving nicely to this direction of thinking about privacy, especially as we collect data. How might this impact somebody? And I thought the industry was developing a lot of necessary muscles around thinking about how we collect data. And now with AI and machine learning kind of taking over literally everything that we're thinking about, I feel like we've gone the opposite direction to say that we should just collect everything and analyze it and use it to inform these models and to train these models. And I worry that the work that we've done to think about the privacy concerns around collecting data, and maybe even moving to a mode where as we collect the data, or we build a function that's going to collect the data, we also build the capability to delete the data after it's no longer useful, or to abstract the information that we need from it and remove the raw data, because that creates a lot of exposure. So I would say as an industry, we need to think very carefully about data collection while we're considering the purpose for which we're collecting it, even if we are thinking about how we want to use it to maybe train new models or what have you. but consider also that we might not recognize all the privacy considerations around it, and that we have to be good custodians for that data. And part of being a good custodian is deciding that the data is no longer required for a business purpose or no longer required for a purpose that your project has, and delete that data.
I could not agree with you more about privacy concerns. I wanted to make sure we get a chance to open up questions to the audience. I think we probably have about 10 more minutes, right? Does anybody else have any questions for us that we wanted to make sure to cover? Anyone? Don't be shy. We're a small group here. It's a community. Okay, we've got one over here. Kahil is going to bring you a mic.
How did you get your start on the security space? Before college, before, the companies, did you even think you were going to be in the space?
How did I get started in the security space? There was no, security space, really, when I got started. I learned to program really early on a TI 99.4a with a book called Programming TI Basic. And I'd copy in the program, and then I'd change it a little bit and see what happened. So I had early exposure to this. I had my mother was a software engineer, and so I got a lot of exposure to it. When I went to university, I had an interest in mathematics and computer science, which led to an interest in cryptography, which led to an interest in cryptanalysis. And my first exposure to a multi-user operating system was mind-blowing to me. And immediately I started asking the question of what's keeping my data separate from everybody else's, and what's keeping my process space separate from everybody else's. And the answer back then, and this is the early 90s, the answer back then was nothing. It was very open. It was designed to allow resource sharing, et cetera. So I started building software tools to exercise this, let's say, alternative access. And eventually identified that there were other people that also had an interest in alternative access, and that there was a whole community, in fact. So when I found this community, I already had my bag of tools, and so that was fantastic because I had something to contribute. And this was an environment that really loved to share with other folks. And so, found a community of folks who were also interested in what became known as security research. And Boston was a very rich community. There were a couple of pockets. There was Berlin, there was Boston, there was Buenos Aires. There were a couple of places where folks came together to examine alternative access, and that was really lovely. So before there was much of a software security industry, there were young people who really enjoyed learning how systems worked and how to circumvent the mechanisms that were designed to mitigate access.
That was a delightful answer. Do we have time for another question? Do we? No, we do not. I'm so sorry, but that was fantastic. I too started on a TI 99.4a with BASIC. This is fabulous. Thank you so much, and thank you all.